Today.
Sir, whenever in Google we type some term and we see the results, we get on the first page sometimes that did you mean this particular thing? So, is that an example of NLP?
Could you please repeat? Sorry.
When we do some search in Google
Mhm.
and we get some results, but sometimes there is also a mention on the top telling that did you mean something else, like
Huh.
whether we made a mistake in our search term. So, is this a natural language processing?
Yeah, the technique used is obviously very primitive technique for natural language processing. So the way natural language processing uses it uses some kind of word net, a network of words, and it will kind of figure out whether this is a typo, and that is how it asks. So yes,
Okay.
yeah, some techniques. So NLU or NLP is a big branch, and some of these are already being used. So interestingly, when you ask question to Google in a way that what are the three ways to do something, so it also uses some these techniques, NLP technique, to really understand
Okay.
what are you asking. Actually, the whole idea that Google search is striving is that you ask a question without thinking about how to search, and they should be able to give the right answer. So nowadays, you see, if you ask this kind of question, how many states are in India, for example, you directly get the answer. You don't even need to go to a page. It will give the number directly. So if you search with specific questions, it will actually give the answer immediately. It will not even, you don't need to even click a link. So that is the ultimate thing that they're trying to do. That is all about natural language processing.
Yeah. Thank you.
Yeah, any other question on what we discussed yesterday? Okay, so let us start with today's topic, that is, and we'll start now with big data. So big data, obviously, when you talk about data science, big data pops up very obviously. However, when you say big data, definition also is kind of keep on changing. So uh, people used to talk about terabytes of data as a big data, but nowadays people talk about petabytes as big data. Terabytes is not considered to be a big data per se. But big data is not only about volume. So volume is one aspect of it, which is obvious from the term big per se. So big in a way, so it's a volume. But there are other things which comes in. The second thing is the velocity with which the data comes, and that is obviously more applies to social media kind of a data, or the data coming from sensors of a machine. So that data is coming, is kind of keep on coming, and that is where the data set, which has a volume and velocity, both are important. Even in the transaction system for large organization, for example, if you're talking about Walmart kind of organization, the point of sale transactions, when somebody kind of buys something at a Walmart across its retail stores, I'm sure that data is also velocity is very high. So again, we could even term it as a big data, though it may not be. I think it is because volume also is very high, but it may not qualify as a big data because of third reason, which is variety. So if it's the same data, same type of data, some same structured data, then we may not like to call it a big data. Uh, we like to call it as big data only if there's a variety, and variety could be different types of data. So social media data is typically, there are likes which are coming, there are shares which are coming, the retweets are happening. There are different kinds of data which is coming in. Then there's a veracity. Now, by the way, when we're looking at this big data, there are three V's which people talked about, which is volume, velocity, variety. And then people started wondering about the truthfulness of this data. How likely this data could be true, particularly social media, where people are actually concerned that a lot of data that you get could be junk data. Or when you're talking about data coming from sensors, you're not really sure whether that sensor data is all time correct, or is there a malfunction in the machine and because the data is not correct. So you have to be very careful about it. And the truthfulness is what veracity is. The term veracity is used largely because you wanted to have a 4V, so we use veracity per se. But it essentially means truthfulness. How quality of data is it really falsified data or the true data? And the fake is a value, and ultimately the data set is worth processing only if it's valuable data. So obviously, we're talking about social media. The data is valuable simply because we are worried about the branding, particularly digital reputation, online reputation per se. Hence, that data is of importance. So that social media data will be very of high value to consumer companies more than to say B2B companies. Again, B2B companies also matter. For them, the consumer social media data matters simply by the branding in a sense. Like for the Larsen and Toubro Limited may not be selling so much to individual consumers, but it would be worried about what is being talked about L&T in social media. So from that perspective, yes, for them it is valuable. But for Dabur or for Patanjali, social media data will be much more valuable because their brand reputation is definitely they need to monitor it, they need to shape that perception and so on. So from them, this is more valuable. So we will talk about data sets, we call it the big data, only if there are these five V's, they're characterized by these five V's. But frankly speaking, uh, you know, we can call something a data, big data, if this can't be dealt with traditional data processing software. So traditionally, we have been using databases like Oracle or SQL Server or Microsoft SQL Server, MySQL, and those kind of databases. Now, when the data is too big, when it is kind of the additions are happening at a higher speed and then the variety is there and so on, you really can't handle with the traditional software, and hence you need a different set of software and kind of hardware, but essentially software to process that data, and that is where the big data should be seen. Now, in the context of data science, when you're looking at actionable insights, you need not have big data all the time. For a company with a sales data, which is not necessarily big data, it's still a valuable source for actionable insights. So when you talk about data science, majority of time actually people really don't refer to big data because for many companies they will not necessarily have that big data. Okay, if you're talking about Walmart and those kind of a large companies, you will definitely need big data. I mean, you have those kind of a data. But for many companies, this is not really the case. However, when you see data science, both big data and what you can small data, regular data, you could kind of count, and that processing would be there. And as I said, the definition of big data would keep on changing. Uh, Earlier it was terabytes, now it's petabytes. Some point of time it will become exabytes and so on. And I'm sure the way the data is exploding, you will have more and more data coming in. Now, why this data is exploding? This is, I'm sure some of you might have seen this. Within a minute on the internet in the year 2020, uh, some 52,000 plus users got connected on Teams, yeah, or Zoom, I guess. Then 500 hours of video got uploaded by users, and so on. So, there a lot of data is getting generated. And one reason why people say that data science is the thing to stay is simply because the data is getting generated continuously, and organization need to think, how can we use that kind of a data. Obviously, it's not only about social media. We talk about the 6,000 plus packages being shipped. So that is also there, and there is also a big picture. So this is a smaller version of this big picture, where obviously it's more of you see kind of a social media data, but I'm sure equivalent data or similar kind of a data could be also generated by the transactional systems, and obviously a lot of data could be generated by the machines or the sensors put in those machines. So big data is going to stay. I mean, it will be there, and that is a reason why data science will always be exciting field to go ahead. Okay, so that's about big data. Any questions? Any doubts? I hope I'm not speaking too fast. I just now realized that I was actually speaking fast. Yes, Shani.
No, sir, you're not fast. The pace is correct.
Oh,
No
yeah.
doubt.
Shrey has a question. Please explain more about veracity. So veracity means truthfulness, and these five V's are being talked about as a qualifying criteria for to say whether this data set uh, is big data or not. So volume, velocity, variety would be there. But for example, if you are getting data from machines and the sensor data that you're getting, but the data is but the quality of data is not really up to the mark. I mean, the many times the sensors do not work properly. You get all zeros or some random numbers and so on. Then that we say the data set's veracity is low, and then we will not obviously like to process that kind of a data whose veracity is low. So we want to process only that data, or like to call only that data as a big data, where the volume is high, velocity is high, variety is high, veracity is high, and the value is high. So veracity will essentially means the quality of data. So I mean, when you have a large volume, very small portion of the data maybe may not be correct, but the majority of the data is not correct, or if the quality of data is very low, then there is no point in processing that data, no point in calling this a big data. Yeah. Does it answer your question, Shreya? Okay, thank you. Now, another term that is talked about in the context of data science is business analytics. And this has been the term which has been used, I think, even before data science became popular. Now, if you really look at the definition of it, it basically says the process of using quantitative methods, or actually, you can use the word statistical methods. It's a process of using statistical methods to derive meaning from data in order to make informed business decisions. So, if you see, look at this definition, it doesn't look much different than what we saw as a data science thing. And then there is always kind of a Google queries which says, what is the difference between data science and business analytics? And it's very difficult to kind of, you have very precise answer. But the way I like to give answer, more in the Indian context, that if you're looking for doing MTech, you do MTech in data science, and you will do MBA in business analytics. What does really mean is that data science is more technical. You would need to know something more about computer science also. Some programming would be required, some understanding of programming, or some programming actually required to be done in data science. Whereas in business analytics, you are more focused on using statistical or quantitative techniques to solve business problems or to answer business queries, essentially. So from that perspective, business analytics, the focus is more on the business side, understanding or responding to business questions. And hence the tools that could be used, the technicals or techniques to be used would be similar, but it is just that something is more technical and something is more business analytics. We also joke around saying that earlier there used to be a subject called business statistics, or rather, there used to be a subject called statistics in MBA curriculum, first year MBA curriculum. Then it was renamed as business statistics to make it more interesting to students. And now it is renamed as business analytics. And you teach almost the same thing in all these subjects. But now it is called business analytics, so people take more interest in it. And there is obviously more interest in doing specialization. So people do MBA in business analytics specifically. but the terms are also very loosely used. So many times you say people are doing saying they're studying data science and business analytics. But I guess majority of, I mean, if you really see a very high level view, you can say something is more technical and something is more business aligned. So that is how you could look at it. Business analytics also has three types. First is called descriptive analytics, which is nothing but finding out what is happening. So again, uh, if you understand statistics, you know this is something called the descriptive statistics. So you try to understand what the data is telling you. Maybe what is the central, uh, what is the tendency, what is the central tendency in a sense, what is the mean, mode, median, then the standard deviation and variance and those kind of things. So basically, it's telling what the data is describing. So you describe the data essentially, which is which has been there. All MIS reports, for example, we used to refer to earlier, are nothing but descriptive uh, analytics. I mean, the sales report that company publishes are basically nothing but descriptive analytics. Predictive analytics is where you want to predict, and this is something always interesting. I mean, uh, if I spend 5% more on advertising spend in next quarter, how much more can I expect in sales volume? That kind of a questions could be answered with predictive analytics. You want to predict, and this is obviously of interest to business users because nobody knows the future, but you want to try to predict as much as possible. So that is predictive analytics. Prescriptive is where you make prescription. You just tell this is how we should be done. So people talk about prescriptive analysis in purchase, where some auto-generated purchase orders could be placed for low-value items based on what is the current level of inventory and what kind of a projected demand and so on. So you could actually generate purchase orders automatically, and that is nothing but a prescriptive. I mean, prescription is given, just tell what to be done, and sometimes it will be auto-generated, sometimes something could be done automatically, or it could come as a recommendation saying that do this, do that kind of a thing. So that is what is called prescriptive analytics. The technology that enables this prediction or prescription is the same technology that we use in data science. So in a way, if you're studying business analytics or you're studying data science, you're almost studying the same thing, though there could be more focus on business side when you're doing a data analytics course or data studying data analytics area per se. So, any questions on this? Because I know there could be some confusion in this regard. Okay, so far so good. So, time for to take a quiz. Right. So we have kind of said we have demystified it. So let us try to understand. Okay. So I'm just putting three big areas: computer science, domain knowledge, and maths and stats. So when I say domain knowledge, it would typically mean business domain knowledge, but it could be very specific, like a marketing domain or financial finance domain, or it could be healthcare domain, or it could be education domain, or it could be even government kind of a taxation domain and so on. So it could be a specific domain knowledge. Okay. So and I'm putting some arrows like a superset. So what is that field should be called which makes use of domain knowledge, computer science, and maths and stat?
Sir,
You can
data
use
science?
yeah, you can put in the chat box. That could be good. Or if you have difficulty in using chat box, then you can unmute yourself and speak up. Okay, so Shalini is saying data science. Okay, what about others? Okay, so it's a branches of data science. Fine. Any other responses? Okay, Shairi ma'am is saying business analytics. Okay, so let me show the answer and then we'll discuss it a little later. Okay, so we call it data science and we can discuss about it. Let us say now what would be the mix of domain knowledge and maths and stats? What will you like to call that?
That would be business analytics. Yeah.
Okay, okay, so that could be business analytics. Shalini also said business analytics. Okay. What about what that is which requires domain knowledge and computer science? Domain knowledge and computer science. Yes, Shiny ma'am.
Machine learning.
Okay. Let us put that machine learning. Okay. And what will be a mix of computer science and maths and stat? Reporting is what Sonali is saying. Data science is what Hemant is saying. Okay. So let us see the answers. Okay. Do you agree? Don't agree? Please uh, ask questions. Do you agree? I mean, you can say it yes or no in the chat window or unmute yourself and speak up. Okay, so Hemant is saying yes. Okay. Now, since these are buzzwords, many times you will hear people saying something which is, you know, kind of creates confusion. And even before I putting this slide, I was like thinking through a lot and saying whether it is a right slide to put in. But just to have a consistent understanding about what you're talking. Data science is something which requires, I mean, if somebody wants to become a data scientist per se, need to know a lot about computer science because you're doing some programming. You're actually using data structures and algorithm. You need to have understanding of all that computer science field. You're obviously making use of mathematics and statistics, and you need to have a good domain knowledge. And that way, I mean, maybe this course is fundamental data science, so I would like to put this as kind of combination of it. Business analytics, uh, we would say, may not need so much of understanding of computer science because you're not really getting into programming, and that is where you will see MBAs are typically do business analytics, and they need to obviously understand what is SQL, what is SQL, and they need to understand what is Python, and but they need not have a very deep dive in that. And business analytics typically would mean these people will work along with clients, with business users, and they would be more concerned about understanding business requirements and trying to solve them with statistical techniques. But statistical techniques, obviously, you'll not do on paper. You'll obviously use some software. So you need to know the software for for using the software. But business analytics will prefer not to use Python and R, but would preferably use some tools like SPSS and those kind of tools, which will more statistical tools, but which have good GUI, and they can get some answers very quickly. They can analyze the data without getting into doing some programming. So that way, business analytics, we could say it's more with the domain knowledge and maths and stats kind of thing. Information systems traditionally use obviously programming and data structures and algorithms and those kind of things, and you require to have domain knowledge. So that's a traditional system development. So if you're building a software for a company, you need to use software technology, hardware technology. Plus, you need to understand business. So I think that's pretty much information system. Machine learning is something one can. So somebody who's specializing in say machine learning, then obviously that person needs to know computer science and needs to know statistics and maths in depth. And you can't really say that a machine learning expert will not understand business, but that's something could be done better by a team of a machine learning expert and the business analytics people. So, frankly speaking, when you talk about data science project, or for the matter, even business analytics projects, they are team projects. So, though the article which I shared on the day one about written by DJ Patil and Professor Devanpur, data scientist is actually a team sport. Data science is a team sport. You really will have very few people who would be versatile in all three fields: computer science, domain knowledge, and maths and stats. Where it is not a child's play, essentially. And as we'll see in the last session about career choices, uh, people have started now using two terms: expert data scientist and citizen data scientist. And why these terms are: expert data scientist is the one who's actually what is in great demand, and that is what that article refers to. So DJ Patil himself, we could say, is expert data scientist because has a full understanding of blending of computer science, domain knowledge, and maths and stats. So yes, expert data scientists would know all three things in depth. But a citizen data science would know something in depth, one or two of these, and some understanding of other fields, so on. So why I'm showing this slide also is because data science is not easy. So if somebody is really looking at becoming a data scientist and that too expert data scientist, it's a difficult thing to achieve, and that actually will ensure that there will be perpetually high demand for data scientists. Simply because it's not very easy to have somebody who understands statistics very well, even though application part of it, but still very good understanding of statistics, who understands or is a good programmer or understanding programming very well, and who has a very good understanding of the domain knowledge, or understand domain issues. Now, having that kind of person is not easy, and hence the demand for such experts will always be there because companies will like to hire someone. Not only companies, I would say governments will like to hire someone with that kind of skills. But eventually, when people talk about data science and different roles, so even if you see many roles getting published, or job requirements coming with data scientist, if you really see it, they are not really looking at data scientists. They're looking at somebody who is very good in statistics and can work with Python and R, so some kind of computer, and has a basic understanding of business, or somebody who has a great good understanding of business, a kind of MBA kind of a person, has understanding of statistics and does not carry a phobia of Python and R. And eventually, companies will deploy a team of people who will have different specialists, and there could be a one person who knows everything at a superficial level, maybe, and then you could work as a team and deliver a project. So data science projects, classical data science project, that's what we'll see. So data science process would require all these skills, and it may not be easy, but definitely possible when you're talking about team approach, where you have some people who are focusing on machine learning, some people who focus on business part of it, and some people who are basically programmers essentially. So that team approach would definitely work. Yeah. Any questions so far?
No,
So
sir.
now we will, yeah, yes, Shalini.
No question, sir.
Okay. So let us look at which business challenges are being addressed. Now, these business challenges are not the ones which we could address only because data sciences came. This has been there all the time. Data science has made it easier, or maybe actually speaking, less costly, so to say, to deal with these challenges. So, from that perspective, we are looking at these challenges. So, first is anomaly detection or fraud detection, disease detection, crime detection. So fraud detection, particularly in credit card industry, is a classical problem, and lot of many technologies are used to actually look at that kind of problem. Obviously, credit card industry requires to work in fraud detection, so they may make use of very high-end, expensive technologies to kind of solve these problems. But a fraud detection is a problem which I think every organization faces, and data science could be used to kind of resolve this kind of problem. Uh, Crime and disease detections is more requirement for government. Which government needs to figure that out. And again, these are not the problems which could be solved only now because of data science. They have been solved earlier also, uh, but now they have become a little, what you can say, more feasible in a way, or more cheaper or better or faster solutions are possible with data science. Then classification, and I think the example which is we talked about spam filter. So spam filter now it is pretty easy to develop, and it has become a routine. I mean, any email software that you use, you will have a spam filter. So that's pretty straightforward. Forecasting is again a very classical problem or classical challenge for any business. Every business wants to forecast sales or revenues or customer retention, and there are always some models being developed over there and how we can uh, you know forecast or predict what could be the revenue or what could be the profit in next quarter or next year. So those kind of problems could be handled. Pattern detection, whether it could be weather patterns. Again, weather patterns is, uh, I mean, at a very high level, people have been using it. Very different technologies are being used. Uh, Financial market patterns is obviously the $1 million or $1 billion kind of a question, a goal that would be always pursued by companies. Recognition. This is something which uh, becoming more feasible now, thanks to data science technologies. So these technologies were very high end, very proprietary earlier, but today they could be uh, done. I mean, this could be used by kind of companies nowadays, thanks to data science and recognition in terms of facial, voice, text. Now, handwritten text, for example, is always difficult, but handwritten digits is pretty easy, and actually that technology is matured very well. So today, recognition of handwritten digits is pretty easy. That's the reason you see these checks could be processed without any manual intervention. So nowadays, the reason the checks are deposited faster is because they're actually scanned and the digits are kind of recognized by the machine, and the technology seems to be almost 100% accurate. However, in India, we still many banks, or rather, I think all banks are required to still use humans to at least verify it. So after the money, the transaction happens, still there are people who kind of look at it. So there are a staff like State Bank of India, for example, has a staff team which just check whether what is the, say the they see the scanned copy of a check and they see the what is scanned, and they verify it. And if there's not correct, then they will obviously flag it. And this may happen, uh, the transition may happen even before this verification happens, or sometimes it may happen a little later. Depends. I mean, but the whole idea is that the technology is matured enough to detect the handwritten digits. But when it comes to handwritten text, we are still not reached that level. So, prescription given by the doctors, uh, though it could be scanned and it could be recognized, you still need some humans to kind of understand that handwriting. So, there are promising things in there, but facial recognition also is becoming very important, particularly with the CCTV cameras. But again, we have not reached that maturity of technology where it is pretty easy. But yes, we are moving in that. Recommendations is one which has really picked up, and whether you use so Zomato, for example, uses data scientists and the whole data science team out there. Uh, it's so much working on building this solution, the Zomato app, the recommendations. Netflix is, I mean, it's actually, we can say, data science company in a way, because the kind of recommendations that make, and Netflix has reached a level where they produce new web series based on what are the likings of their customers. So they can actually predict that if you make a web series with this actor and this director or this plot, this location, shooting location, and so on, this is going to be more popular. So they actually use all this data analysis and the insights coming from data science to develop the storyline and to hire actors and actresses in their web series. So it is that level of recommendations that they're using. Obviously, Amazon is big player in this to an extent that Amazon is working on the technology, rather it is matured enough that they can deliver something to you even before you order, because they know that you need it at that point of time. So they can actually make a deliveries without you even placing an order. But when you receive it, you would find that you really need it. You'll actually accept the delivery and pay for it. So that kind of that kind of actionable insights are possible with data science. Now, it was not that it was not possible 10 years back. It was possible obviously with Amazon and Google and Facebook, but with the technology maturing enough, it is possible for the larger number of companies, which essentially means that many new people can start working on it, and that is where the career prospects for data science is high, because there are more opportunities for people who could use this technology. The technology, I think we like the word democratization. So it becomes more democratic in a way. It is no longer confined to only Facebook, Google, Amazon, but can be used by Janta like us, and we could address these business problems at a lower budget than what was possible earlier. So, any questions on this? Any doubts, questions? So we looked at business challenges, and I said this business challenges will be always there. But what has changed is this enterprise applications have become ubiquitous. I mean, they are something which every company now has. I mean, uh, even the small mid-sized company nowadays have enterprise applications. So data is there. Data is getting accumulated over the years, right? So that kind of contributes to the popularity of data science. Social media, we have always seen the kind of data generated in social media, and many times people actually say that it's kind of, you do not really need to look at social media data as the data which you must process and you must look into, examine to get actionable insights. But for consumer companies, it's still a valuable data, so that needs to be looked into. Mobile computing typically since people are using mobile and mobile are location, you can actually track the location of a user. So a user ordering something from a desktop gives some data to the to the retailer. Suppose he's ordering on Flipkart, but when the same person orders on Flipkart from a particular location, that addition of that location data gives some more insights to Flipkart. So mobile computing becoming important because people are now acting on things. They're buying, selling. They're doing a lot of things, uh, and the location, the precise time and the location is all uh, kind of reaching out to this company. Companies can gather that kind of a data, and that gives additional insights. So that is another reason why mobile computing is important. Internet of Things, all the sensors which have increased significantly. I mean, today a company having offices, large offices, have so many sensors placed in that again the data gets generated. So much of a data gets generated, and you could actually look at the data and try to see what you can do with the data. So Internet of Things is becoming important. And enhanced computing power. I mean, what the computing power your mobile has now was something which is the early stage computers all didn't have. Large scale computers didn't have that kind of power that we have now in our pocket or in our hand. So, and obviously your desktops and with machines, this enhanced computing power is also helping us to process that kind of a data. And finally, cloud computing is fueling it much more. I mean, the whole reason the cloud computing has become so important for data science is because today you don't need to really need to own large machines to do data science projects. Majority of data science projects nowadays actually happen on cloud. So there's no reason why companies need to buy hardware for executing projects. We're not really sure whether this will give us actionable insights. They can actually invest in renting virtual machines on Amazon or Microsoft Azure or IBM Cloud and execute data science projects. And if they get something great, if not, you're not really get stuck with those high-end hardware. So cloud computing has reduced the requirement to invest in buying hardware. That is number one. Number two, when I'm using a data science platform, for example, if I want to use, say, IBM Watson Studio, I need to install it in the desktop or any machine, and I need to kind of set it up, uh, which it's itself a kind of a task. But when I'm using it in cloud, it's all taken care. Now, IBM Watson is still a usable piece of software. But if you're talking about some big data software like Hadoop or Spark and this kind of tools, setting it on our machines itself, you know, requires good amount of skill, and you need people with the technical skills to manage those kind of software applications on in-house machines. When you use cloud, you need not have that technical expertise. You just use it kind of out of box, so to say. And that also makes it easier to do data science project. I mean, it kind of reduces the cost, it reduces the hassle of hiring people with different skill set because it is all managed on the cloud. It doesn't make it too cheap, but definitely economical to execute data science projects. So cloud computing has become very, very important. And today, if you see cloud computing vendors offering, whether Amazon Web Services or Azure or any of these IBM Cloud, you will see that the majority of offerings are around data science, machine learning, deep learning, and those kind of things. Interestingly, Google would outsource or open source, not outsource, open source the software for deep learning, which is TensorFlow. We'll talk about that later. And there is a very interesting comment that instead of selling the software, they have made it open source so that anybody can use it for free. But the software is so complex that you need to use Google Cloud, preferably, obviously, any cloud for that matter. So they make more money with that cloud business rather than what money they would have made in selling the software. So they actually open source software. So one of the good thing about data science is that majority of software tools are free and they're open source, but they're not easy to manage. So you preferably work with cloud versions of those software, which are obviously not free, but reasonably priced and with all operational expenditures. So easier to manage with, even for the companies. So these are the enabling technologies which we need to be aware of. So that completes our section of demystifying data science. And I just want to confirm that as everybody's sort of got that demystified, or do you have any doubts, questions, something that you heard which you are not able to relate uh, with what I said so far. So please let me take a pause here for a minute and see if there are any questions. Yes, Anand.
Yeah, Shrikant is Hemant.
Yeah.
So I think most of the data science processes you have covered over here in terms of business challenges, in terms of technology enabling, and also the domain specific areas. And so only thing which I'm only part which I'm looking is again data science is being processed, which is across the domain, correct? So it could be different domains. You have different processes which are added to the industry wise, correct? So is there anything any links or anything related to for example, I'm just looking for healthcare industry, for example, or something kind of. So you have some links or something so that we can able to explore how it is being used, the data science in that industry. So industry wise also it could be differ, correct? So it is all what you have given is a vanilla or a overall process, correct? So but again there could be some plus minus things will be there in terms of technology because there are a lot of ERP technologies are there. Then there are some homegrown tools are there. There are a lot of mix and package based systems out there. So again, so that kind of if you have some of those information links, yeah, that will be appreciated. That's what I would feel. But I think most of the points are covered here. And the big data which I was looking is now what you have given the characteristics of big data. So those are good, but most of the tools like big data for SAP is HANA, and for the technologies mostly people use Hadoop and those. So those are things, but they are again. It's not a structural query nowadays. It is all something columnar based and those other things, queries and those. But yeah, those are again low level technical things. But yeah, so I think that's all I was looking. So any other thing which if I missed, you can add to me. But I think that's what I see as a data science as a process. Yeah.
Yeah. So yes, so we will discuss data science process and then the tools that are specific that will be used in data science later. But I think the one interesting point that you raised about domain. So the business challenges that we looked at, typically we are seeing the BFSI, banking, financial services, and insurance domain is more tech savvy than say manufacturing domain, so to say. However, when it comes to data science, we see it's more being adopted obviously in financial services, but also by the consumer. So it is more driven by the sales, the functional things, the sales, customer retention, and those kind of domains, and then fraud detection and those kind of things. Again, coming from the PFS, financial services kind of domains. So most till now, people talk about data science. They are not as much packaged as for the industry. So if I want to draw the parallels, people were talking about ERP earlier. They were talking about ERP as a software, and you become an ERP expert. But then later, when it become kind of mature, people started very specifically saying that ERP for construction domain, that is my specialty. So eventually we will have, so if you don't have a software perspective, but you talk about expertise, then somebody may say that I'm data scientist with a focus on banking domain. So I do data science for banks, or I do data science in healthcare, or I do data science for government. So that specialization for a particular domain would happen more for the people than in software. Software remains generic because it's pretty technology. But people will start building their expertise in a specific domain. Because if you're becoming a data scientist and you understand finance domain in and out, then obviously it's not very easy for you to switch to healthcare domain where you need to understand healthcare domain in and out. So you will see more and more people start talking about being data scientist for healthcare domain, from say BFS domain, so on. And possibly there could be some solutions that could come in with data science, which could be very specific to a domain. And when you talk about these algorithms and we talk about certain tools, I'll touch upon that. That there are certain domains which are more specific. I mean, there are some solutions, particularly in machine learning, that are more specific, becomes very specific to certain domains. So we'll talk about that as we go on. But very good point that you mentioned about business domain person.
Yeah, and I'm just to add on to it is just a MDM, okay, master data management or something MDM solutions, because it's industry wise they have different models or something are there, so which is always a very high cost, and also you don't use everything what is being given by that model. You use a subset of that, and then you explore, and then you make on that, correct? So that is all. We as IT solution, we always do that, correct? That's all.
And interestingly, business analytics, if you see, where it's more focused on quantitative methods for solving this business problem, user specialization happening more there. So you talk about HR analytics and marketing analytics and finance analytics. But things more interesting is things like sports analytics, which is actually makes use of. So there are fintech companies will use data science very extensively, or there are retail companies which will use kind of make use of data science specifically for the industry. So yes, I mean as the technology become more mature and more available, you'll start seeing some specialization happening there, and that is where people will start building their own niche offerings. So the companies will start building their own niche offerings. So there are companies who are focusing only on sports analytics, for example. That's a huge field. Sports analytics is a huge field, and the way the data science used in sports per se is really very high end technology is used in sports analytics. So those kind of specialization would happen, but I guess that will more called as analytics than called data science, simply because so much focus on business person. But actually speaking, it's still the solutions used for sports analytics, will make use of some computer programming and obviously the domain there, and then the lot of machine learning kind of models which are there. And eventually we'll also see some models being developed which are specific to a business problem of a particular industry. For example, talk about underwriting in insurance. So there could be a data science packaged solution only for insurance underwriting. and that kind of things would happen. It is not so much there as of now, but the future may be actually more in that. That you build solutions which are very specific to a particular business process, like insurance underwriting, and then offer it to insurance companies globally. So that could be a uh, future approach that some companies or individuals can take. Yeah, we have 2 more minutes, so instead of starting a new topic, let me see if there are any questions or comments or doubts. So we'll close in a minute, but just let me show this uh, process which we are talking about. So we're talking about, say, formulating question, acquiring data, preparing data, analyzing data, reporting results, and act on results. And in that, the first one and the last one, the formulate question and the act on results, is actually not part of data science. So when I say data science, it starts with acquiring data and reporting results. That's all. It actually doesn't uh, include the first or the last step. The reason I have put that, because the question that I have posed is, how does data science deliver value to business? And for data science to deliver value to business, you need to first formulate question correctly, and lastly, you have to act on results. If you don't do that, then this whole data science process becomes actually useless. So that's the reason why I've added these two steps. But typically, if you look at data science process, it starts with acquiring data and ends with reporting results. So we'll see this process in detail in tomorrow's session. And as I said, please post your queries, if any, on WhatsApp group. And tomorrow when we start, we'll again take their queries from whatever we discussed so far, and then we'll start with the data science process. Okay, so can we close the session today?
Yes, sir.
Yes, sir.
Yes. Okay.
Okay then. Yeah.
Thank you.
Say tomorrow.
Yeah.
Bye.
Yeah,
Thank
same.
you, sir.